The first nuclear power plant in the world was called the EB-1 trial reactor. It was constructed in the U.S. state of Idaho and put into service on December 20, 1951. Scientists were wrong when they believed they had invented nuclear power at the beginning of the 20th century. Before we discuss the actual origins of nuclear power and what may be the planet's oldest nuclear power facility, the Soviet Union established a nuclear power plant shortly after in 1954, which at the time was regarded as unsettling. The first commercial nuclear power station to supply electricity to the public grid was Calder Hall in the United Kingdom in 1956. People saw nuclear power as a major development in technology and an indication of human progress. But still, discovery. In 1972, a French company initiated the extraction of uranium ore from Gabon, a country in Africa, for the nuclear industry. During their mining endeavors in the southern region of Gabon, they unearthed not just conventional uranium, but an extraordinary discovery. As workers delved deeper into the mine, they stumbled upon a unique metal composition distinct from typical uranium forms. Upon analysis by French scientists, these samples revealed an unconventional composition. Ordinarily, uranium samples consist of isotopes with varying atomic masses, uranium-238 being the most prevalent, uranium-234 the rarest, and uranium-235 the most sought after due to its capability to sustain a nuclear chain reaction. Surprisingly, the Gabon samples held minimal uranium-235, indicating its near depletion. The remaining uranium, 0.717%, was insufficient for use in nuclear power plants. This perplexing discovery led researchers to question whether this mine was a natural occurrence or harbored a deeper secret. Further investigations unveiled astonishing revelations. The examined samples exhibited traces of having undergone a nuclear reaction equivalent to about 200 kilograms of power, comparable to 6 atomic bombs. Remarkably, despite the presence of used uranium ore, there were no signs of an explosion or a major uncontrolled nuclear reaction. This suggested a controlled nuclear activity within the mine. Dating back around 2 billion years, this mine appeared to have been utilized for nuclear power for approximately 500,000 years. During this extensive period, a controlled and sustained nuclear reaction generated a considerable amount of thermal power, equivalent to several hundred terawatt-hours, similar to the output of an average nuclear power plant spanning several decades. With the passage of 1.5 billion years, any remnants of the nuclear reaction had vanished, and the highly radioactive nuclear waste had naturally decayed. This revelation astonished scientists, unveiling the existence of a technology akin to the work conducted by 20th-century physicists, an astonishing 2 billion years ago. Shocking facts. A consortium of global scientists united to investigate an astonishing find. A mine housing uranium ore that appeared to be a sophisticated underground nuclear reactor rather than a natural phenomenon. Oddly, it lacked typical technical apparatus like pipes, cooling towers, and control cabinets. Nevertheless, experts confirmed the controlled nature of the observed nuclear reactions, ruling out extreme scenarios. The mystery deepened as they pondered who might have operated a nuclear reactor 1.8 billion years ago using an unknown method. Initially, the prevailing belief dismissed the possibility of a natural process. Dr. Glenn T. Seaborg, a renowned nuclear scientist, asserted that burning uranium in a reactor was not a natural occurrence but a product of human intervention. He explained that nuclear fission necessitates slowing down neutrons to the required speed, typically resulting in very hot water that evaporates. Nuclear power plants use specially treated water for this purpose, not found naturally in the same form. However, Dr. Seaborg's conclusion was later challenged. In a 1956 scientific paper, another expert named Paul Karuta suggested the potential for a natural nuclear chain reaction. Even skeptics had to entertain the notion that nature might possess a level of intelligence comparable to humans, possibly creating the first natural nuclear reactor 2 billion years ago. The precision of this ancient reactor surpassed what could be purely attributed to natural processes, leaving scientists intrigued and continuing investigations into its origin. Meanwhile, nuclear physicist Alex Meshik and his team from Washington University in St. Louis revisited the Aklo site in Gabon, 30 years after the initial buzz around the natural reactors. Their return yielded a remarkable discovery. The natural reactor functioned for exactly 30 minutes before remaining dormant for 2 to 2.5 hours, then resuming energy production. Intriguingly, further analysis revealed that the nuclear reactions occurred at different points within the mine. The team contemplated how such precise timing could align with a natural process. Alex Meshik's team posited a potential explanation. The cycle of 30 minutes to 2.5 hours might correspond to the rate at which water seeped into the reactor from its surrounding environment. Certainly, despite the natural explanation, the Aklo reactor continues to captivate scientists and atomic energy experts due to its construction and operation. Some speculate about alternative origins, suggesting that these caves could have served as an energy source for ancient civilizations or potentially visiting entities from outer space. While this notion might sound far-fetched, it resonates with rumors surrounding ancient Egypt, the Mayans, and even Venice, hinting at secret energy sources and reactors. 2 billion years ago, Earth's crust was likely in the process of cooling, allowing for the formation of large land masses. If any life existed during that period, it would have been simple organisms such as single-celled organisms or basic algae. Today, scientists continue to utilize Aklo's reactors to study how highly radioactive nuclear waste naturally decays in the environment. The natural breakdown of waste at the Aklo site offers hope to scientists and the global community, showcasing the potential to eventually manage large quantities of radioactive waste, including plutonium, without burdening future generations. Please like and share our videos. Don't forget to subscribe to our channel and press the bell icon for regular updates.